Hi everyone and welcome back to chemistry. This is Mrs. Hutchinson and today we're going to discuss matter and change, and we're going to talk about our final aspect of matter and change and how to distinguish among matter given experimental results. So here's the question. We have two samples, they're sent to a lab and various tests were performed. So we've got our two samples. We've got sample 1 here, we've got sample 2 here. Test 1 is filtration. So sample 1 was able to be filtered. Sample 2 was not able to be filtered. So that really tells us a lot about what sample 1 actually is. The only type of matter, so the types of matter that we're looking at are homogeneous mixtures, heterogeneous mixtures, compounds, and elements. So, what's the only type of substance, of matter, that's able to be filtered? It's a heterogeneous mixture. So sample 1, right off the bat, being able to be filtered, is a heterogeneous mixture. That is a physical separation. That means that we're looking at things that were physically combined, which means we had to look at the mixtures themselves. And the only type of mixture that's actually able to be physically separated through filtration is a heterogeneous mixture. Next, we have heating. We took sample 2 and we heated it, and we found that it contains 2 different boiling points. Okay. So if it was not able to be filtered, that means it could either be a homogeneous mixture, it could be a compound, or it could be an element. But it was found to contain 2 different boiling points. That means that it contains 2 different substances. That means it was used or separated through distillation, most likely, which is a physical separation. Distillation is a physical separation, so we must be talking about a homogeneous mixture. So our telltale sign for what sample 1 had to be was the fact that it was able to be filtered. And for sample 2, what gave it away for a homogeneous mixture was that we had 2 different boiling points. Okay. So on the next slide, what I want to really show you and discuss even more is what a distillation setup looks like. We've seen it in class, or at least discussed it in class, but I want to make sure that we have it on a video somewhere so people can reference it. So taking a look, this is a setup for distillation. Distillation separates using boiling points, separates mixtures, homogeneous mixtures, using boiling points. So here's what happens. You've got your mixture here. So this is our mixture, our beginning mixture of at least 2 substances. Let's say we're talking about, let's do ethanol and water. So they're both colorless liquids. They have 2 different boiling points. So what we have is a mixture of alcohol and water. We put it into that flask. When we turn the burner on, what's going to happen is whichever one has the lower boiling point, which happens to be ethanol. So ethanol's boiling point, I can't remember exactly, but let's just say for right now it's around 60 degrees Celsius. It could be. I can't remember exactly, don't quote me on that. But let's say it's 60 degrees Celsius. When this And water's boiling point, as we know, is 100 degrees Celsius. So when we heat up this mixture to 60 degrees Celsius, what's going to happen is that ethanol is going to boil off, become vapor. It's going to rise up our distilling flask and into our condenser. As it moves through the condenser, it's going to be cooled and, well, condensed, and start to drip out the end of the condenser into our receiving flask, and that is known as the distillate. So as we hit 60 degrees Celsius, that ethanol begins to boil and move through our condenser and into our receiving flask. After a while, or a little bit, all of the ethanol is going to be boiled off, and it's going to be in our receiving flask. We can then turn off our Bunsen burner here, and we would be left with just water over in our distilling flask, and just ethanol in our receiving flask because our ethanol boiled off first. That's how distillation really works. Separate substances using their boiling point. The substance that has the lower boiling point is going to boil off first. So I hope that helps enlighten you in terms of really what's going on with distillation. Let's move on to our next example. So we've got 2 samples. They're sent to the lab. Whoa, that was silly. 2 samples. Sample 1, boom, right here. Sample 2, right here. Test 1. Well, there's only one test. I like it. Chemical reaction. Sample 1 did not react and was not able to be chemically separated. Sample 2 was able to react and able to be chemically separated. So when we're talking about things that are incapable of being chemically separated or capable of being chemically separated, we're talking about either compounds or elements. So remember, our mixtures are physically combined, therefore they're physically separated. So, if sample 1 was not able to be chemically separated, we don't care about the fact that it didn't react. I don't care. It has nothing to do with us classifying this. But sample 1 was not able to be chemically separated. So which one of these is not able to be chemically separated? Well, that would be our element. Remember, it's the simplest form of matter. So it's not able to be chemically separated. Bam. Sample 2. I don't care that it was able to react. I don't care. Doesn't have anything to do with it. But sample 2 was able to be chemically separated. So, it must be a compound. Because it was able to be chemically separated. Okay, so, therefore, we know what we're talking about for question number 2. Moving on to the next one. Question numero 3, because I never took Spanish. They're sent to the lab. Sample 1 over here, sample 2 over there. So test 1 is filtration. Sample 1 was able to be filtered. Sample 2 was not able to be filtered. That tells us right off the bat, if something is able to be filtered, it's able to be separated physically. That means that we're either talking about a heterogeneous mixture or a homogeneous mixture, because physical separation means that it was physically combined. So therefore, if it's able to be filtered, only one of these types of mixtures is able to be filtered, and that would be our heterogeneous mixture. So sample 1, right off the bat, is a heterogeneous mixture because it's able to be filtered. Sample 2 was then sent on for further testing. It says after heating, sample 2 A solid was found left behind, which was tested and found to be salt. So after heating, okay, so that means that sample 2, some heat was added, something happened to it. Solid was found left behind and found to be salt. That is telling us that we had something, if it was not able to be filtered, it's either a homogeneous mixture, a compound, or an element. But now it's saying we found something left behind and it was salt after we boiled it. Okay, so we boiled off our water and we were left with salt. Salt, as we know, dissolves in water and creates a homogeneous mixture. So, sample 2 must be a homogeneous mixture because the solid was found to be dissolved. Remember aqueous? So remember aqueous? That tells us that we're dealing with a homogeneous mixture. So here's a thought question. What would we classify NH4NO3 as? Would we classify it as a heterogeneous mixture, homogeneous mixture, compound, or element? Well, let's take a look. We've got 1, 2, 3, 4 capital letters. So multiple capital letters is indicative of us dealing with a compound. The name of this substance is ammonium nitrate. So ammonium nitrate sounds like a compound. It is a compound. So it's a compound because it has multiple capital letters. Again, I'm just going to give you the name of it. Ammonium nitrate. Okay. So NH4NO3 is in fact a compound. Law of conservation of mass and energy. This is just me restating the same thing. We do talk about the law of conservation quite a bit. We talk about law of conservation of mass, energy, charge, momentum when you get to physics. So pretty much in life, a lot of things are conserved. Essentially, what the law of conservation of mass and energy state is that you can't create nor destroy matter or energy in any physical or chemical change. In other words, what you start with in terms of mass and energy is always what you end with. The mass of the reactants will always equal the mass of the products. And people are like, well, what about when you burn wood? You don't wind up with the same mass at the end. Well, yeah, you do, because you're giving off gases. So if this is like, I don't know, our little fire pit thing with fire. Oh boy. See, there's our fire pit. That's not a good drawing, but we're going to go with it. So as we're burning off the wood, we're giving off gases. Tons of gases. If we had a way to collect all of that gas and take the mass of it and take the mass of the ashes of our wood would be equal to the mass of the ashes of the wood plus the mass of the gases, I should say, would be equal to the mass of the wood itself. So, mass of the wood would be equal to the mass of ashes plus mass of gas. So the mass of our reactants, our wood, what we started with, would be equal to the mass of our products, the ashes and the gas. That's what we mean in terms of law of conservation of mass and energy. What has been here since the beginning will be here until the end, and essentially, you can't get something from nothing. As much as you want to, something has to be present in order for you to obtain something from that. That's the law of conservation of mass and energy, and law of conservation of matter. So now, classification of matter, distinguishing using experimental data. So what we're going to do is take a look at this particular question, use your notes to help you. So we have two samples, they're sent to a lab and various tests were performed. So the first one would be magnetism. So magnetism, the first thing that we think about is that is a physical separation. You physically had to do it. So if it's a physical separation, we're talking about mixtures. Sample 1 was able to be physically separated using a magnet. Sample 2 was not able to be physically separated using a magnet. So sample 1, since it was able to be physically separated using a magnet, that means that it's not uniform throughout. So it's got to be heterogeneous mixture. And how do we arrive at this? Able to be separated using, magnet. Sample 2, it was not able to be separated using a magnet. Okay, so it doesn't really tell us all that much, but it does tell us later on that sample 2 was able to be filtered. That is again another physical separation. The only type of mixture that can undergo this type of physical separation is a heterogeneous mixture. So in this instance, both of our examples turn out to be heterogeneous mixtures. Different heterogeneous mixtures, but heterogeneous mixtures nonetheless. So that concludes our end of Unit 1. So if you were confused on any aspect of Unit 1, go back and take a look at any of those videos. If you have any questions for me, I will see you in class, and I will see you for our next video in Unit 2.